The neo4j knowledge graph project is an example of a simple queryable knowledge graph implemented using neo4j with a node command line interface implemented in TypeScript. This is based on a Python example created by Roberto Piericini at Jibo. A nice tool for viewing and live editing neo4j graphs is called Graph Editor and is available at www.lib.org/graph-editor. It has helpful features that will be used in this example. One extra note about Graph Editor is that you can import a static version of the animals database by using the import function and navigating to the docs folder for the project. And then you can open up Graph Editor animals.json, and that will pull in a static version of this graph. Then you can generate the cipher for this graph by clicking on the cipher button and copy and paste that into neo4j. So that's just a useful feature that Graph Editor provides. So in this example, you're going to want to connect to a neo4j graph, ideally an empty graph. The easiest way to get that set up is to download the neo4j desktop application, which looks like this. Here you can create a new graph. You can add a new graph. I've already got one running here. And then you can view that graph using the neo4j browser. So we'll do that first. So this graph contains a very simple knowledge graph about animals. We can see the whole graph in the browser here. So here we've got all of the information about animals, a little extraneous information over here from a different example. So the browser is a good way to look at neo4j graphs, but it doesn't allow any real-time interactive editing of the graph. So I like to use Graph Editor. So I'm going to switch over to Graph Editor. Again, Graph Editor is available at WwLib.org. It's an Electron React app built with Webpack. So you can set up Graph Editor to connect to that same neo4j database. And if we take a look at the setup here, we'll look at the details. We can see that we're talking to a neo4j graph using the Bolt protocol at that URL. The graph name is neo4j. You have to put in the password. And then when the graph first loads, it runs this particular cipher here. So if we load up this animals graph, then we're going to get back this initial cipher, which basically returns all the is-a relationships in the graph, which gives us a good look at the animals and their types. So we can see that invertebrates are animals, vertebrates are animals, birds are vertebrates, mammals are vertebrates, and then of the birds, in our database here we have penguins, flamingos, and albatrosses. Of the mammals we have whales, armadillos, zebras, and bats represented. Of the insects we've got flies and butterflies. Now if we take a look at the mammals here, we can view the properties of each animal by clicking on them or double clicking. So if we double click on penguins, let's say, we'll get a little panel here that allows us to see the type and the name property and any other properties that were defined. And these can be live edited. So if I change the type and I hit save, it'll change it in the neo4j graph. And if I change this little property here, name or robot likes, those will also change in the neo4j graph. So I won't change those right now. But it does make it easy to edit the graph. So if we now take a look at the example, so if you need to set up this graph, which of course you will doing this the first time, then you can get the cipher for the graph in the docs folder. And this cipher here will instantiate that graph. So if we were to copy this and paste it into the neo4j browser, if we pasted it in here, command return, it would instantiate this graph. I won't do it because the graph's already instantiated, but that cipher will get you going. Now, we also need to configure NLU. So this example is set up to work with Lewis and Dialogflow. And in order to set up the intents and the entities that we'll need for the example, you can choose to use either Lewis or Dialogflow, or both. You can switch between them. And then you're going to want to, for Lewis, upload the Lewis knowledge graph JSON file that's in the docs folder, and that will define a whole bunch of intents and entities. And then for Dialogflow, you would upload this knowledge graph zip file, which has, again, a whole set of definitions for intents and entities. And then you would modify the config file in the data folder. You would copy this config-example and make a config.json file, and then in that file you would put your Lewis endpoint and your Lewis app ID and your Lewis subscription key if you're using Lewis. And you would put your Dialogflow client token in here if you're using Dialogflow v1 API. If you're using the v2 API, you can leave the client token blank, or you can populate it. But you're going to also need the project ID, the private key, and the client email. If you have all that information for Dialogflow, then you can talk to the v2 API. And then to talk to the neo4j database from the example, then we have to put in the neo4j information, the URL, the username, and the password. So you enter that information, save it as config.json in data, and then the example will find it when it gets built. So to install, we do yarn. I've already done it, but we'll do it again here. All right, it's already installed. To build it, we'll do yarn build. If you change the config, you do have to build it again because that config file is loaded via a require, and it gets built into the code. So we've rebuilt it here. Now we can start it with yarn start or yarn debug. We'll use yarn debug because it displays a bunch of helpful information as it runs. Okay, so now we have a prompt, and it says ask a do you like question, or say user likes something. Well, let's start with our favorite question. Do you like penguins? So we get back the intent and the entities that Lewis recognized. We get a launch do you like intent, and then we get back a thing, which is penguin, and thing original, which is what I actually said, penguins. In this case, we're not using user information, so those are coming back with the defaults I set to just be someone. And then we can see that the answer that comes back is, I like penguins. I kind of look like one, and I know that Cynthia and Andrew like them too. So we'll go look at the database and see why that's true. But in the debug console here, you can see that the dialog manager that we'll look at goes through a couple of different steps. First, it checks to see if the robot likes that node already. So, do we like penguins? Well, in this case, we do. We get back a result. We do like penguins. And then we want to see if there's a user that also likes that node, that likes penguins. And so we issue another cipher here. We're gonna match on every penguin node that is liked by a user, and we're going to return the list of users. So in that case, we get back an array of users, which includes, in this case, Andrew and Cynthia. And so then the dialog manager builds the response out of that result. So I like penguins, I kind of look like one, and I know that Cynthia and Andrew like them too. So if we go over to the graph, we take a look at likes, run that query. So we're going to, in this case, we're going to match everything that likes everything. We'll see what's in the database. So we've got, well, Andrew in this graph likes cheese and whales. And Cynthia likes the robot and penguins. And if we take a closer look at the penguin node, oh, actually, I forgot to point out that Andrew likes penguins too. So that's why we get back both nodes. If we look at the penguin node a little more closely, we can see that it has this robot likes property where it has a special message. I like penguins and I kind of look like one. And so that got used in the response. Not all the animal nodes are going to have a special response. For instance, armadillos, there's not a special response. So if we come back here and we say, do you like armadillos? So it checks to see if we like that node. Turns out we do. Checks to see if there's any other users that like that node. There aren't. So then the response comes back, yes, I do like armadillos very much, which is the default response. Now if we look for another node that has a special response, a special robot likes response, we can ask about whales. We'll get back, you know it, one of my favorite animals. And we'll find out that Andrew also likes whales. So let's try it. So here, yes, I like whales directly, and I find out that there's one node in the response about users liking whales. So here's my response. You know it, one of my favorite mammals, and I know that Andrew likes them too. Pretty cool. So let's ask a question about an animal that the robot does not specifically like. So if we go to the entire graph so we can kind of predict this, then let's see. What I really want is this query here. Turn off the bubbles, it makes it a little hard to see. So here we've got the robot. We know what the robot likes. Whales, zebras, flamingos, penguins. But the robot doesn't specifically like bats. Now the robot does like zebras, which are mammals, and whales, which are mammals, but he doesn't like bats specifically. So let's try asking about bats. Do you like bats? All right. So in our output here, we see that we're going to check to see if the robot likes that node, and the result comes back empty. No. So now we'll check to see if there are descendants of that node that are liked by the robot. Now in this case, bat doesn't have any descendants, so that comes back empty as well. As you can see up here, bat sort of is the leaf in this little tree. So what it does find out though is it tries an upward reference. So it checks to see if whatever bat is, does the robot like that? And so an upward reference looks kind of like this link here, match bat with any node that it is, and then see if the robot likes that. So that comes back with a bat is a mammal. Well, the mammal class includes bats, whales, and zebras. So if we run this upward link query here, we'll get back what the little example got. We're going to get the fact that whales, zebras, and armadillos are also mammals, and that the robot likes them. So what we see here is that the response comes back with this array with 4 elements in it. I don't know if I like bats, but they are mammals. So the first element in this array is the mammal node. And I do like mammals. Of all the mammals, I like armadillos, zebras, and whales. So the robot was telling us that he likes armadillos, zebras, and whales, and that's consistent with the graph. And of course, that's because that's how we define this graph. So then let's try one more interesting query. Let's tell the robot that someone likes something. So we know that Cynthia likes penguins, and Cynthia likes the robot. Let's tell Jibo that Cynthia likes armadillos. Now, right now, there's no relationship. There's no likes relationship between Cynthia and armadillos, but we'll tell the robot there is. So we will say, Cynthia likes armadillos. Okay, I understand that Cynthia likes armadillos. So we did a query. We're going to match armadillo, and then we're going to use that thing in the next query, and we're going to actually establish a relationship. We're going to use the merge command to establish a likes relationship between the user and the thing that we like. It's kind of wrapping there, but so now if we take another look at this likes query, if we run this again, turn the bubbles off, we will see that now there is a likes relationship between Cynthia and the armadillo. But let's say, you know what, we want to edit that. So let's double click on that relationship and delete it. So now if we ask, do you like armadillos? He'll come back with, yes, I do like armadillos. But because we deleted that link, he doesn't add the fact that Cynthia does too. So that's a quick run through of the example. If we take a look at the Dialog Manager class, we can see that we're importing the controllers for Lewis and Dialogflow, the V1 and V2 API controllers. We're importing the neo4j controller. The Dialog Manager gets instantiated with some options, which in this case is just whether or not we're in debug mode. So we've been running debug mode here, so we get this verbose output, which is helpful. And then the option also indicates whether we're going to use Dialogflow or Lewis. We use Lewis by default. The Dialog Manager has an ask method, which takes a query and a context. Contexts are used by Dialogflow. They're ignored for Lewis requests. And then we send that request to the controller. And because these controllers all implement the abstract NLU controller class, all the controllers have a call method, a get entities with response method, and a get intent and entities method. So in the Dialog Manager, once we've defined or once we've instantiated our controller, we can use it interchangeably. That's a quick run through of the neo4j knowledge graph example. There's additional information in the documentation included with the repo.